have you ever wondered what the secret is to a perfect pancake recipe? Or maybe how to draft a winning fantasy football team? Or even just snag the best deal at the grocery store? Well, it's not magic. It's actually a really simple but super powerful idea called a ratio. And today, we're going to show you how it's hiding in plain sight absolutely everywhere. So what is the link here? You've got cooking, you've got map reading, you've got sports. What's the common thread? It all comes down to one single concept: ratios. They are kind of like this invisible language we use all the time to make sense of the world by comparing one thing to another. So here's our game plan for this explainer. We'll start with the absolute basics, then we'll learn the language of ratios. After that, we're going to take our new skills out into the real world, and finally, I'll show you the #1 trap people fall into so you can steer clear. Let's get into it.
Okay, first things first, let's build that foundation. To really get a handle on ratios, we need to be crystal clear on what they are at their core.
The key phrase here is multiplicative comparison. Now that sounds a little fancy, but all it really means is that we're thinking in terms of how many times, not how much more. So for example, if your recipe calls for a ratio of 2 cups of flour to 1 cup of sugar, it just means you need twice as much flour. Simple as that. It's a relationship based on multiplying.
So if ratios are a language, how do we, speak it? Well, like any language, it's got a few simple rules for how we write things down. And the good news is, it is super easy to learn.
As you can see, you can use a colon, you can write it like a fraction, or you can just use the word 2. But here's the thing. They all mean the exact same thing. You read every single one of them as 3 to 5. You'll see all 3 out in the real world, so it's really good to recognize them all.
Okay, now this is probably the single most important rule to remember. With ratios, order is everything. If you're comparing boys to girls, the number for the boys has to come first. If you mix them up, it's like telling someone to turn left when you actually mean right. You're going to end up in a completely different place.
And this brings us to the 2 main flavors of ratios. Part to part is what we've been doing, comparing one group, like boys, to another group, like girls. But you can also do part to whole, where you compare one group to the total, so girls compared to all the students. It's a really subtle but super important difference in what you're trying to say.
Okay, so we know what ratios are, we know how to write them. Now let's talk about how to actually work with them. See, just like with fractions, ratios can be simplified or scaled up, and honestly, that's a really useful skill to have.
Simplifying a ratio is actually a pretty straightforward process. As you see here, we're taking the ratio 10 to 15. The real key is to find the biggest number that divides into both of them. In this case, it's 5. You just divide both sides by 5, and boom, you get this simplified but still equivalent ratio of 2 to 3. And this is a huge takeaway. The ratio 10 to 15 represents the exact same relationship as 2 to 3. You can think of it like a photograph. You can shrink it down or blow it up, but the proportions, the relationships inside the picture, they stay exactly the same. For every 2 boys, there are 3 girls. Doesn't matter if the group has 25 people or 250.
So why do we even care about this? Why does it matter? Because this is the secret to scaling a recipe up for a party or down for just yourself. It's how you figure out which box of cereal is actually the better deal. Understanding equivalent ratios is the key that unlocks all sorts of practical, everyday problems.
All right, theory is one thing, but let's see how this stuff actually works out in the wild. This is where ratios stop being just numbers on a page and become a legit tool you can use every single day. You know, you probably use a special kind of ratio called a unit rate constantly without even realizing it. A unit rate just tells you how much for one. Think about it. Miles per hour, dollars per gallon, price per ounce. It's all about simplifying that second number down to 1. So, how do we use these equivalent ratios to solve problems? We use something called a proportion. A proportion is really just an equation that says, hey, these 2 ratios are equal. And the cool thing is, if we know 3 of the numbers, we can always find the 4th. Let me show you how that works. Here is a perfect real-world example. Every single map has a scale, right? And that scale is just a ratio. It connects the distance on the paper to the actual distance in the real world. So here it's 1 inch on the map for every 5 miles on the ground. So here's the puzzle. To solve this, we just set up one of those proportions we were talking about. We know that 1 inch is to 5 miles, so we set that equal to our new ratio. 4 inches is to what? Our unknown number of miles. With that simple little equation, we can find our answer. Okay, for our final section, let's talk about the most common mistake people make with ratios.
I mean, everybody does it. And if you can understand this one trap, you'll have truly mastered this concept.
This is the #1 slip-up I see. It seems kind of logical, right? To get from 2 to 4, you add 2. So you just add 2 to the other side to get 5. Makes sense, right? But remember what we said at the very beginning about what a ratio actually is?
And the answer is a big no. This goes right back to our core definition. Ratios are multiplicative, not additive. You have to multiply or divide both sides by the same number. To get from 2 to 4, you multiply by 2. So you have to do the same to the other side. 3 times 2 is 6. The correct equivalent ratio is actually 4 to 6.
And that's really it. In just a few minutes, you've basically learned a new language. You can now define ratios, you can write them, you can simplify them, and most importantly, you can use them as a tool to solve actual real-world problems. That's a pretty powerful new skill to have in your back pocket.
So my challenge to you is this. The next time you're cooking or shopping, or even just looking at a map, try to spot the ratio. Now that you can see this hidden code of comparison all around you, how are you going to use it? Thanks for tuning in.